anything else we can. And 31 we'll go over again. If you have other questions, please let me know before we move along here. These are always tough ones. This is one of those multiple choice problems. I believe this is the one you're asking about. The 14, does that look right? It's a multiple choice one. Yeah, okay. These are always tough. It said, which one does not allow you to conclude that AD equals CD? So we have to kind of like process elimination, eliminate these. So it's a little bit of a annoying one because once you kind of see it, find it. So I'm going to do some marking and then I'll do some erasing, kind of depending on what we know here. So they say AE equals CE, and then they tell us BEA is 90 degrees. Now, in this case, we could be able to figure out that these top triangles are congruent, but again, we're trying to figure out that these two angles are congruent, so those top two don't do anything to help us. So I'm going to cross those out. That one doesn't work. The next one is that BA equals BC. Again, they're kind of hanging out on top up there. And then BDC, BDC, well, that one's a little bit better. BDC, and then BDA. Now, this one is a little bit tricky as well because the triangle we're talking about is this. We have this angle, we have this angle, and then we have the shared side in the middle. What property is that? It's ASS, which we can't do, right? No. So that one doesn't work either. So that one's one of the bad ones. So that one's out. Can't have that. The next one is AB equals CB. So up here, like that's what we just marked, AB equals CB. Now this time they're telling us ABE up here equals CBE. That's up here. So now this time, just changing that little bit. We have this top angle, this side, we got to have the shared side in the middle. This time we have side angle side, so I think this one's going to be okay. We can prove these triangles are congruent by side angle side, and then by CP, CTC, we can figure out that. So I think it is C. And I think this one is another scenario where they're using just those top angle, that top triangle up there. All right, then I'm going to go to number 31. which was on page 255. Oh, so this is the proof that, I know I talked with like Luke about this one, and at first he like was missing it, and as soon as we drew the triangles a different way, I think it makes a lot of sense. So this is one where you just really have to look at what they're talking about in this case. Because they actually give you a lot of information, So this is all a given. Sorry, I should have probably just put that in my proof. Oh well. So that's the given information. What we're trying to prove is they're trying to prove ABK equals CBJ. So we're trying to prove ABK equals CBJ. Okay. So this is why it's confusing, because ABK is this triangle, and then CBJ is this, or sorry, CBJ is this triangle. So I'm going to draw those two triangles completely separately. So ABK. Now I know that double angles here, this is there for us. Then I also have this triangle. Double angle, single angle. But then if you look at also what they gave me, they told me AK equals CJ. Once I draw these triangles out separately, we have enough information to prove that by angle side angle, that these triangles are congruent. We don't even have to do any kind of extra steps. It's a two-step proof. We put the given statement in, and then by angle side angle, we can prove they're congruent. So this one's more a matter of realizing that this is, you know, like not a great drawing there, but it comes from that part of the triangle. Okay? So there are no other questions. We'll start our new notes for today, but I do want to kind of explain to you guys our schedule for this week. It's a little bit of a strange week. So I'm going to make sure we're all knowing what's going on. Because technically this week is the end of the semester. That means we're supposed to be halfway through geometry for the year. Ooh, we're not quite there, but not that far off. I couldn't get much better. So let me explain to you guys this week. So today we're doing new notes. Okay, so I guess I need to talk about Friday too. So this is the end of the semester. Now, I could probably rush to do notes today, rush and do a review day, and then do a test. That would mean the next day after that we would have an exam. Our exam in here is on Thursday. If you haven't kind of gotten some of, I know Miss McDonald's been sending out emails about this, I'll give you guys a better example of the schedule. But our exam is on Thursday in here. So rather than trying to rush to get a test in, I mean, you guys can blame COVID on this, we're not going to try and rush to get another test in. We're going to review like chapter 4 and also review kind of the semester in the next couple days. So we're going to have a couple of review days here where we're going to review for the exam and also chapter 4. Now chapter 4 is going to show up on the exam, but I'm not going to have a separate test with it. We've tested a bunch in here already, so I think we're okay in terms of not having to fit another test in. Now, if you're still thinking of retaking a previous test, that needs to be done soon. So make sure you guys get that taken care of. Now, with us taking an exam on Thursday, just know that an exam is not something to absolutely freak out about and think that everything's gonna, like your grade's gonna go in the tank. If you're doing fine, the exam's gonna be fine for you, I promise you. It's really just everything we've learned so far this year. And you have the advantage that we haven't really done together that long this year. And so the amount of time you have to remember all that stuff is a little bit less, which maybe is not the best thing in the world, but it works for us this year. So we're learning new notes today, but then we'll review for a couple days and we'll take our exam. I want to give you guys our exam schedule. I should have done it before. So this is the next couple of days. And I'm a total schedule person, so if this schedule helps you, use it. If it doesn't, feel free, I'll send one back. And our email that we got this week about the schedule is a little bit different. Oh, that's right, I gave you one on the air. I'm the only person I have in the air that actually teaches. So Ms. Miller, do you, the email we got this weekend said that the Thursday morning study session is now optional, I believe? I don't know, she sent us the email yesterday, and that's what I read on it, but, okay. So we'll have her, let me know if that sounds right here. So if you guys look, our exam time on this sheet is Thursday morning, but later than we typically have it. So this kind of changes your schedule as well. But since the exam then is 9:20 to 10:50. Now there's time before that. So if you have to take the bus to school, know that you guys can come and hang out in here and study. And report the first period. But does it say optional? Okay, yeah. So you're supposed to come to your first hour class. So you guys are supposed to come here and sit with me. If you guys just need someplace quiet to study, you're welcome to be in here. If you guys have questions, I'd obviously be glad to go over things with you and kind of answer last minute questions. It's a pretty big chunk of time. So, but it says it's optional on there, so that means if you can get a later ride or whatever, you guys can come later. But if you're at school, you're supposed to be in your first hour class. Now, let's say you're really, really needing help in chemistry or something, and you're good in geometry. We could probably make something work with, your other teacher. So just let me know if there's someplace else that you'd rather be. I mean, hard to believe, but if you're thinking about being someplace else, just let me know. We'll get it worked out. But so our exam on Thursday is from 9:20 to 10:50. Now, I anticipate the exam taking longer than a normal test. It's a little bit bigger than a normal test because of the fact that it covers basically 4 chapters versus just 1. So kind of plan on having that whole time to test. So that means if you have questions, you need to come before. So it's not like a normal day where we'd answer questions before and kind of make sure you guys feel good to go. 9:20, we're getting going on the exam. If you notice, then we have a normal lunch and AR that day. And then after that, you go to your 3rd hour exam. And then the afternoon there is kind of the part that you need to know about. Is if you have missing assignments, if you're not on up to date with all your classes, you have to come during that exam study session. So that is only optional if your work is complete. And so by Wednesday, all your missing work must be in. Because on Wednesday, you're going to get an email, or we're all going to get an email saying Drake, you're good to go. You have all your work in. You have to stay for that extra study hall, if you're not caught up to date. So if you're good and you know all your missing work is in, then you're good on Wednesday. On Thursday, you'll have that afternoon free. Now, if you would take the bus and don't have another way home, you're still welcome to stay. Or if you want to work with a teacher or something like that, obviously, we'd love to have you. It's just some people would prefer to go home. And they can only go home if they have all their missing work in. Does that make sense? You okay with that? And then Friday's schedule is totally different. exams 2 and 4, it doesn't impact our class, are in the morning, and then there's a grab and go lunch, and there's even buses at like that 11 o'clock-ish time. The makeup exams is basically like if you missed an exam for some reason or another and need to come in and do that. Or maybe if you have other work to make up for your teachers, okay? So Friday, I'm not seeing you guys at all unless you're doing a makeup exam or you're doing some makeup work for me, okay? So Friday's essentially like a half day. Yes, good question. Yes, I will let you guys have a note card, which my note card is not really like the little note card because I don't want you to like have a practice on like making things fit into a small space. I just do it like a half sheet that I card stack. I'll bring it for you guys tomorrow. My opinion with the note card is if you make a really good note card, you probably don't even need it. It's just kind of a nice little backup to make sure you guys kind of don't have to like cram everything and just kind of, I think it's a really great study tool, like putting everything in one place, kind of putting the things from our charts on there that we've made this year. So yeah, you have a note card. I'll bring it for you guys tomorrow. Yes.
Can we use both sides?
Yeah. I don't want you to have to squeeze. That's why I make it big. Just like when I've made it smaller, it's just been like a who can write the smallest like test, and that's not a great use of your time. So I'd rather it just be bigger. Other questions? All right, so it's the blue sheet. Yeah, kind of fill in your classes. It's a little bit of a weird exam. This typically isn't like those new or ninth graders. This typically isn't how exam week works, but it's what we're doing this year, and it is what it is. So trying our best to make it work. Yeah.
So for the exams on Friday, it's on Thursday. The first one is your first period one, and then your third period one.
No. Oh, it should say exam. Oh, dang it. I'm sorry. This is wrong. Wait. No, it is 1 and 3. That's right? Okay, it's 1 and 3. No, it's right. Yeah, it's 1 and 3 on the first day. Sorry. So like your odd classes on the one day and then even on the other. Sorry. Yes.
So it's first period, third period on Thursday, and then the second period on Friday.
Yes. Sorry. So your first and third exams here, and second and fourth. Very good. Yeah. I said that, and then it sounded wrong, and does that make sense? Good clarification. Other questions, you guys? So that means at this point, you guys should be checking in on Infinite Canvas, on your Schoology. You guys should be aware of where you're at in all your classes. And if you're not in agreement, like if you say to me like, well, I really had those assignments turned in, like Wednesday would not be the day to say that. You know, like talking to me today and tomorrow, making sure that you agree with what it says in Infinite Campus. Like if it says something's missing, I don't know. I mean, I have everything up to date. I think you guys know that typically my grades are pretty close to up to date. And if it's in there, I think we're good to go. But if it's a 0, I haven't seen it or I need to see it. So talking to me today and tomorrow about that is going to be really important. Questions? Good questions so far, guys. But let me know if more stuff comes up. I know it's weird and it's a different schedule. I'm sure your other teachers are going to be talking to you guys about it too, but I just want to make sure we're all feeling okay. All right, so we're going to move on to notes here. So your 4-7, if you guys haven't looked at it already, there's a warm-up question about isosceles and equilateral triangles, which is something we have talked about a little bit. All right, so what do you guys know about isosceles and equilateral triangles, or one or the other? when you guys write down. I know some of you guys wrote stuff down, so. You guys know. Izzy, what'd you write down? Okay, so yeah, we're talking about sides. So in an isosceles triangle, two of the sides are the same length, so two congruent sides. Two congruent sides and then equilaterals, she said it, all three are congruent. Now, I think sometimes on the definition, some people debate between is isosceles an equal or is an equilateral and isosceles triangle? It kind of depends on your definition. So an equilateral is kind of a special isosceles triangle. It obviously has two equal sides, but it has all equal sides. So two congruent sides, and then all three are congruent here. Does anyone else remember anything about the angles we talked about? We talked about this a couple I think it's been 2 chapters now. So what do we know about the angles of those isosceles and equilateral? Do you remember about the angles? Yeah, go ahead.
They all equal 60 degrees.
So in an equilateral, they're all the same and they're all going to be 60 degrees. Very good. So 3 congruent sides, but also 3 congruent angles. And I think we mentioned this about isosceles. Does anyone remember? There's something about isosceles and their angles. About their base angles. I feel like it was in our chapter like 2 or something. Maybe I'm wrong. No? So I don't remember now. So base angles are congruent to isosceles. So isosceles has 2 equal angles as well. Does that sound familiar or no? It makes sense, but you're like, I don't know if we learned that. Yeah, I don't know.
A few weeks ago.
What's that?
A few weeks ago.
Oh, did we do it then?
Yeah.
Okay. It seemed familiar. I'm glad that at least Peyton got something out of that. Thank you. All right. So we're going to talk about isosceles and equilateral today, and kind of talk about things we can know based off of them being having those congruent sides, having those congruent angles. So we'll use those in our problems here today. So talk more about those isosceles triangles here. So in an isosceles triangle, we have the legs of the triangle, and those are the congruent sides. So the 2 congruent sides are the legs. Think of it, you have 2 legs. Isosceles triangle has 2 legs and the 2 congruent sides. Hopefully your legs are the same length. The vertex angle is what's formed by the 2 legs. So, or it's the angle between the 2 legs. So this is our vertex angle. So it's the angle formed, or angle, sorry.
Please excuse this interruption. At this time, any high school students that would like to have their picture retaken, or students that haven't had their picture taken yet, should report to the Innovation Lab. Once again, high school students that would like to have their picture retaken, or students that haven't had.
Do you know where that is?
Picture reports.
The look on your face. Allie, are you headed there? Can you take it? You know where you're headed? So past, like, on your way to lunch, just go a little bit further. So the vertex angle is the angle formed by the two legs. So it's the included angle with those two legs. And then the base angles, we just talked about this. These are the base angles, are the congruent angles. Now, I drew this intentionally the way I did so that the base angles aren't always on the bottom. So you think about base being like the bottom of something. So the base angles don't necessarily have to be on the bottom. They can be wherever it's equal. So the two angles that are equal, so angle 1 equals angle 2. Those are our base angles. Now, I kind of like thinking of it as the leg is across from the base angle, so that helps. They're across the triangle from the base angles and from the legs. So understanding those vocab words are going to be helpful and just being aware of where everything's located as we try to solve these. So basically the rule down here is telling us if it's a triangle's isosceles, this one says if we have two equal sides, then we're automatically going to have two equal angles. So sides, give us angles. So we have equal sides, we have equal angles. And then the converse says if we have equal angles, then we have equal sides. It goes both ways. This is kind of if and only if idea. So I only really need one or the other. So if I have the sides, I know the angles are equal. If I have the angles, I know the sides are equal. They interact with each other that way. They go both ways. All right, so when you guys are ready, we'll flip our sheet over here. Actually, because I want to give you guys a break here in a second. I've been doing a lot of talking. I'm going to go down to example 2, if we could. Jump down to example 2. You guys want to look at example 2 here with me? So what kind of triangle is example 2? It's isosceles. I heard someone whisper it. It's not a secret. It's isosceles triangle. So it's an isosceles triangle because we have these two equal sides. Now, if I have those two equal sides, the theorem we were just talking about tells us we automatically have what? I heard it. Go ahead, valid. Equal angles, yeah. So if we have two equal sides, that means we have two equal angles. If I have two equal angles, where are the equal angles in this case? Which angles are going to be equal? You guys tell? Which angles are going to be equal? X and Y. How do you know that? You're right. How do we know those two are equal? What did I say about where the base angles are? Where are they going to be in relation to the legs? How do we know where the equal angles are? Because he said X and Y are equal. That's correct. But how do we know that? And we're not just like guessing. Just saying they look equal isn't enough. How do we know they're equal? And maybe we need to write this down. Anyone have it? So the two congruent angles, maybe write this right by the base angles, are across from the legs. So if I go from the leg across the triangle, it's going to run into that base angle. Across the triangle, it's going to run into that base angle. So if you can't figure out where the equal angles are, they're going to be across from those legs. So if you need to write that in there to your notes so you know where those are. All right. So that's how we know x and y are the equal angles. So here and here are the equal angles. Now we've kind of run into an issue. If I set those two equal, what's wrong with our equation? What's our problem? Yeah.
One's an X and one's a Y.
One's an x and one's a y. That's not really helping us here, is it? Any thoughts on what we could do otherwise? Anyone have an idea of how we could figure this out? I know those two angles are equal. I have to think back a chapter here. What do I know about the angles of the triangle? They equal 180. So I know these three together add up to 180. Okay? So this one's 52 up on the top. So I have 52. What do I know about those other two angles? Yeah, Dawson?
They're equal.
They're equal, so,
You minus that from 180. You divide them into 2.
okay. So he's saying take 180, subtract 52, we get what? 128, right? But now that's what's left over for those two angles, which I know are the same. So now we can break those up, like he said. We can break it into two equal parts, and we find out they're each going to be 64. So this is going to be 64 degrees, and so is this. Now, they're not asking me what those angle measures are. They are asking us, oh, what is x and y? But now we know those are both 64. So now can I find x and y? Should be able to, yep. So this should be 64, and so should this. I'm going to set up two equations. So we're going to solve each of those. X and y is looking equal, that's kind of weird. I think they are. That's not always going to be the case, so don't think that just because the angles are the same. The variables are going to be the same. Okay, getting those solved. All right, to get our y alone, we're going to do what? Add 2. And then we need to add the 6. Oops, like this morning. Y is 11. Okay. All right, to solve for our x, well, what do we want to do first here?
Minus 20%.
Thank you. Like I said, it's kind of just a coincidence that this ends up being the same x and y. That's not because the angles are equal, probably not the best example. So similar to here, we're just going to divide each side by 4. All right. So why don't we take a break? Because you guys have been sitting listening to me talk for a long time. So why don't these middle two groups go grab marker boards and markers, please? We'll do some practice with this. You guys want to go grab them? If the markers aren't working, you can always toss them out, not just toss them. All right. So make sure you have a working marker. Yeah, go ahead. Yeah, you know where you're going, right? Okay. Yeah, right. Yeah, that'll be a mess. All right, guys, so if you guys could find X and Y for me, please. Find X and Y. Similar, we just did a little bit easier. Yep. Yes. Yep. 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 Work. Yes, good. First, let me do drawing them. Not quite. When did you take them? What did you do?
I did.
Mine's what? Let's check your math again. Okay, yeah, very good. And then there should be 2 angles on the bottom. So you have to think about what to do there. Yeah. Yes. Work. Yes, sir. We'll do it up here. So we do 180 minus 132, right? Because we know that they should all add up to 180 degrees, and we get 48. But then that's for those 2 angles, and those 2 angles should be equal. So we have to break them into 2 equal pieces, and so we're gonna have to break this up, divided by 2, to find each of these would have to be 24 degrees. Because the way to check when you're done is they should all add up to 180 when you're done. So if you add the 3 up and they add those 3 values and they don't equal 180, we know we're doing something wrong. So we want to check on that. All right, let's try another one here. This one's a little trickier, so let me see if I can keep you guys with me here. Try this one here. A little bit tougher. And again, you want to find X and Y. Keep looking at the answer and then forgetting what it is. You're probably going to want to find X first. Yes, good job. Your X is right, your Y is not. Go back and check on that. Yes. Your X is right, your Y is not. Same one is Calvin. She's not him crossing. Not Talon, sorry. Oh gosh, yes, you got it now. Yes. Yeah. Yeah, you got it now. Can you figure out what you did wrong? Yes. Okay. Both close, but not, so I'm wondering if you just subtract, where'd you get 59 from?
Yeah.
Alright, so what do you know, I think the way you cut it off, just so that way this is right. So, you took that away, but then you can't just divide those like 3 or 2, because we don't know exactly if they're even. So what do you know about the base angles? Yeah, so what can you do instead of what you did? So, they have to be equal. So where are the equal angles here in this one, you guys? Which two are equal? Yeah, so these are the base angles that have to be equal. Don't overthink this. So you know that those two are equal, so set those equal. So set up an equation saying that 2x plus 2 then has to equal that 62. I mean, just like thinking through that in that way. So kind of same thing for you. So I probably think you're trying to do too much at once. So just say that those two have to be the same. There you go, good job. Cool. So you found out x, but you're kind of leaving out one of these. Like these are both going to be equal to be 62, so you have to include them both to figure out the y. Your y is too big. Yeah, you're good. Yeah. All right. So our first step, again, for the people that are also online at home, we know that these two have to be equal. So 62 has to equal 2x plus 2. I think I got most of you guys to this point realizing, so x is 30. Once we know that, a lot of you then wanted to say, well, I know this is 62, and so the leftover from that will give me that y is going to be 88. But if this is 62, this is also 62. So now I have a new triangle where it's 62, 62, and y. So I have to include both of those 62s to find my y. So y plus 62 plus 62 has to equal 180. So some of you had too big of a y value just because you were forgetting about that other 62-degree angle. All right, let's try maybe one more with these. Sorry, I didn't be able to fit that in there. These are angles in here. Sorry, I just can't fit them in. I'm right up big enough for you guys to see. Oh, sorry, I see we're doing whiteboards. I think again about what has to be the same as one another. Probably want to start there, if you're not already. Okay, your x is good, now we see define y. This is good. Yes, I believe, yeah. Yeah, you're wise. Sorry, I was worried I didn't know it for sure. Ooh, what's happening? Let's see. Move the 12. Oh, I think this, oh, I just wrote it down wrong.
Oh.
There's 12 there. So let me give you what you missed. Fill in what you missed. Yes, you're good. Thank you. Sorry, the glare. Yes, you're good. Thank you. Yeah, you're good. Yep, you're good. You're done. There you go. So you don't know that this equals 180. You know that the base angles have to be equal. This has to be equal. Your X is right, your Y is not. See? When you put the 6 back in, you can little. Yeah, you're good. Good. Yes, you're good, sir. There you go. So if you're stuck still, I would suggest saying that the base angles have to be equal. They're across from those legs. So I can say that 9x plus 12 has to equal 12x minus 6. That should be an equation we're able to solve. So you should be able to figure out what x is from that, if you haven't already. And then take that away. Thank you. And then we did, oh, sorry, I guess we did this one example. It's just example 2. There you go, good work. Move this over. Let's start working up here. So I move that smaller x first. Move this 6 back over. So we find out x is 6. And a lot of you guys got to this point. And then once you know x is 6, then we have to put that back in so we can figure out what those angles are. Now they should be equal, so I should only have to put them back into one place. So 6 times 12 or 6 times 9, whatever you guys prefer. 6 times 9 is 54 plus 12 would give me, was that 66? And then this is also 66. That sound right? Yeah. And then we put those together. And they have to equal 180 together with y. And that's where we end up with 48 for our y value. All right, why don't you guys, why is it like this side of the room, take their boards back. Feel free to take somebody else's back for them. You guys, this side of the room, yeah. Thanks. Go back to notes here.
You just touched it.
And then this side of the room.
Take it.
All right, sorry, and then if you guys have it already. All right, so we're going to talk about equilateral triangles next here. So just like isosceles, if we have two sides equals, then we have to have two angles equal, and two angles gives us two sides. The same thing goes with equilateral. So equilateral, like Izzy had mentioned, I believe, was that if we have three equal sides, that means we have three equal angles. But it also goes the other way. If I have three equal angles, I can assume there's going to be three equal sides. So that arrow can go both directions. That's that if and only if idea that we talked about with converse and if-then statements. So if I have three sides that are all equal, there has to be three angles that are equal. Three angles gives us three sides. And like Dawson mentioned, if there are three equal angles, the only way to have three equal angles in a triangle, they all have to be 60 degrees. Because again, 60 divided, or basically 180 divided up three ways has to be 60. So there's the only one way to get those equilateral triangles. So that one makes it a little bit easier that we know that angles have to be all 60 degrees. Now this next example, it talks about the same drawing over and over again. So I'm going to be marking things on it, and I get to erase because my board is technology versus yours is not. So I apologize ahead of time because you'll probably be annoyed with me with erasing and you can't. But I'm going to kind of mark things up here as we go. So they want us to be able to name different angles and sides based on what we know. So it says if AB equals AE, I'm going to draw where that is. So AB equals AE. So they give us that information. Where does there have to be equal angles then? Where does there have to be equal angles? A, B, C. Yeah. Yeah, so what we're noticing here then is there's this little isosceles triangle on the top. So what Luke told us was these base angles would then have to be congruent. So if those are their two congruent sides, sorry, not a very good drawing, then the base angles have to be congruent. So ABC would have to equal AED. And I know it's annoying with all the three letters. So those are congruent base angles. So this is basically trying to take the shape and like think about where are the base angles or where are the sides in relation to those base angles. So now try to figure out where the angles are that they have marked in this case. Again, I'm going to erase. I apologize. So I just marked what they told us are the angles. So you can kind of see with the triangle we're talking about. It kind of looks like it's on the side of this prism here. So if we have those two angles marked, bless you. Nolan, what sides need to be congruent then? AF and AB. So on this triangle, those two have to be congruent. So we're looking at that as our isosceles triangle. Those are the sides that have to be congruent. And you don't have to draw that. I'm just trying to get you to see where I'm talking about, visualizing that. All right, the next one is CA and ADA. CA and DA. CA and DA. What do you think, guys? Ones have to be congruent. Where are congruent? Which ones are going to be congruent on this one? Greg, you can tell us. So these are our two congruent sides.
That would be ACD.
Yeah.
ADC.
Very good. ACD and ADC. These base angles there. Okay. So see if you guys can do the last three here. So it's just three. Yeah, try if you guys can do the last three here. A few minutes. See if you guys can see what they're drawing there. Fill those rest of those in. It's like one more minute and then I'll start talking about them. All right, this next one, they give us these two angles over here. So Julia, which two sides are going to be equal in this case? They give us these two angles. Which two sides? Yep, DA, DE, you are right. Okay. The next one is BCF. BCF there, and BFC there. Kansas, which one would be this one be? Did you get this one? Yeah. BF and BC, very good. And then finally, FA and AH. Kind of the big center triangle there. And then it's just going to be these two base angles down here. So AFH, it's hard to say those out loud, AHF. All right, let's go down to the next example. So I believe it's example 3. You guys could jump down to that one. What do we know about the triangle in example 3? What kind of triangle is that one, Drake?
Isosceles.
Isosceles? What do you think? So technically you're not wrong with isosceles, right? Because that's two equal angles. But if the two of them are 60, what does that other one have to be then?
60.
It has to be 60 as well. So yeah, so you were completely wrong. I said isosceles is just a special, or like, you know, equilateral is just a special type of isosceles triangle. So yeah, they would all be 60. A little bit of a trick question there. So we know all the angles are the same. So what do we then know about all the sides? They're also equal. So any ideas how to set this up? Because I can't set up an equation that has like 2 equal sides and 3 parts to it. What do you think, Luke?
2y plus 6 equals 5x.
Yeah, we can just say they both have to equal 4. They all have to be equal to the same side length, and if one of them's 4, they all have to be 4. So we don't want to set up like this compound equation. We're just setting them each equal to 4.
Interruption. This will be the last call for any students or staff that need to have pictures retaken in Education Lab. Thank you.
Last call. Change your mind. Don't be scared just because you got a decimal. It's okay. You can leave it that way or call it 1.4. All right. And then finishing up with our last couple here. So, kind of similar to what we are doing up on the top. So it says if HG equals HK, then again our base angle should be congruent, right? So this base angle, this HG, actually in this case, could I just call it G?
No, it's the other one. Wait.
G maybe, yeah, G would be okay. K has 3 letters anyway, so we might as well name it. G you could probably just call G. HKG. Or Janus angle. But then they also say if KHJ equals that. Also another isosceles over there. We have this going on here. Then those two sides have to be congruent as well. All right, questions there at all? You doing okay with this? So again, this is our last new lesson we're learning this chapter, or this semester even. So tomorrow we'll start reviewing for our exam. I'll bring you guys note cards. Homework is listed there for you guys. I believe the 4 and 5 is a little, I think those might be some proofs for you guys, just to practice those a little bit from what I remember, but I might be wrong. Yeah, there's a couple of proofs, hopefully ones that are doable for you guys. Thank you, ma'am. And then Gabe, this is whatever you meant.